Hello learners, welcome back on the class of soil and rock mechanics. So I hope you all are safe and doing well. In the previous discussion, I have discussed about the very important laboratory test, that is triaxial test. And in triaxial test, I told you the triaxial test is performed in two stages. The first stage, that is cell pressure stage or confining stage, and in the second stage, that is deviator stage or shear stage. So in two stages, we have seen how to compute the shear strength of soil, and shear strength can be computed with the help of sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. And after that, I told you 2 to 3 different tests are done in triaxial test, and with the help of these 3 test data, either we can compute the shear strength parameter by applying the formula sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha, or by drawing the Mohr circle for these 3 tests, and a common tangent drawn on the Mohr circle, and the slope of that tangent will give the angle of internal friction and intercept will give the cohesion. And the third approach, that is PQ plot, in which Q on the y-axis and P on the x-axis, and the value of Q is taken as sigma 1 minus sigma 3 by 2, and the value of P is sigma 1 plus sigma 3 by 2, and cohesion intercept of that line, that is C double dash is equal to C cos phi, and tan phi double dash is equal to sin phi. With the help of that, shear strength parameter can be computed. So today I will discuss another laboratory test, that is unconfined compressive strength test, that is the special case of triaxial, and after that I will discuss vein shear test. So today I am going to discuss about the type of triaxial test. And the type of triaxial test, I already told you that there are 3 types of possibility. That is, first one is consolidated drain test. In consolidated drain test, in the first stage drainage is allowed, that's why it is called consolidated. And in the second stage, volume change is also allowed, means valve is open to drain out the water. In the second possibility, that is consolidated undrained test. So in the consolidated undrained test, first stage consolidation will occur, that is drainage is allowed, and in the second stage no volume change is allowed, that's why it is called undrained, means in first stage valve is open and in the second stage valve is closed. And the third possibility is unconsolidated undrained. In unconsolidated undrained test, in the first stage drainage is not allowed, that is valve is closed, and in the second stage no volume change is allowed, means valve is closed in both the cases. So in all these 3 types of consolidated triaxial test, how to compute the effective stress in terms of cell pressure and deviator stress. So firstly I will write types of triaxial test. As I told you, triaxial test is performed in 2 stages, first stage and second stage. In the first stage, drainage is allowed. If drainage is allowed, then it is called consolidated. And in second stages, volume change is allowed, means drained. In first stage, if drainage is not allowed, means it is called unconsolidated. And no volume change is allowed. No volume change allowed means undrained. So these are the possibilities of the in the first stage either drainage is allowed means consolidated, and second stage volume change is allowed means drained. In the first stage drainage is not allowed means valve is closed and no volume change is allowed. In both the cases valve is closed. So let us take first test, that is consolidated drained test. It is also called CD test. So in the consolidated drain test, consolidated means in first stage drainage is allowed and in the second stage volume change is also allowed, means in both the stages valve is open. So if I write loading so in first stage and second stage in first stage loading to in first stage is called confining pressure. So let us take confining pressure sigma 3, and in the second stage is called deviator stress sigma d. Total stress sigma 1 is equal to sigma 3 in first stage, and in the second stage it is sigma 1 is equal to sigma 3 plus sigma d. What is the effect of pore water pressure? Pore water pressure U. So pore water pressure in both the stages, as drainage is allowed, so U is equal to 0, and in second stage volume change is allowed means pore water pressure is 0. So effective stress is equal to the total stress. Sigma 1 dash is equal to sigma 1, and here is sigma 1 dash is equal to sigma 1, because sigma 3 dash is equal to sigma 3 because no pore water pressure. So in terms of total stress we can see this is our possibilities in the consolidated drained test. So drainage is not allowed in both the stages. Loading rate is slow. So we can write drainage is allowed, in both stages. Pore water pressure does not build up. We get effective stress, parameter, in this case. Second test is consolidated undrained test. Consolidated undrained test, or it is also known as CU test. So in CU test, similarly loading stress, total stress, pour water pressure, and effective stress. And this is the first stage and second stage. So first stage is called confining pressure stage, sigma 3, and second stage is sigma D. So consolidated means in the first stress pour water pressure is 0, but in the second stage U is equal to U naught, pour water pressure is measured. So here total stress sigma 1 is equal to sigma 3. Here sigma 1 is equal to sigma 3 plus sigma D, and effective stress here is sigma 1 dash is equal to sigma 1 is equal to sigma 3, but here sigma 1 dash is equal to sigma 3 plus sigma D minus U naught, or sigma 3 dash is equal to sigma 3 minus U naught. So these are the possibilities of consolidated undrained test. In the first stage, no pour water pressure is measured, so in terms of effective total stress sigma 1 is equal to sigma 3 plus sigma D. Sigma D is missing in the first stage, so sigma 1 dash is equal to sigma 1 is equal to sigma 3. In second stage, deviator stress is also applied, so sigma 1 is equal to sigma 3 plus sigma D, and the pour water pressure is measured, that is U naught dash. So sigma 1 dash is equal to sigma 3 dash plus sigma D dash, or sigma 3 dash we can write sigma 3 minus U naught. So in CU1 test, first stage drainage permitted, and second stage drainage not permitted. And this test gives total stress parameter, because unless drainage is permitted, stress does not become effective. So this test gives total stress parameter. Last test, that is unconsolidated undrained test, that is also known as UU test. So in UU test, drainage is not permitted. During first and second stage. Simply, sample is initially saturated. So these are the possibilities of the test in the triaxial test. After that, I am going to discuss about the what is the advantage of triaxial test. Advantage of triaxial test. So the first advantage is failure plane is not predetermined. And it is the weakest plane. And it is the weakest plane. So in the direct shear test, we have seen failure plane is predetermined. Mohr circle can be drawn at failure. Third advantage is there is complete control of drainage, as it was not in the direct shear test. And the fourth is there is a mechanism to measure pore water pressure. And suitable for all types of soil. Results are accurate. Now I am going to discuss the special case of triaxial test, that is unconfined compression test. So in unconfined compression test, confining pressure is 0. It means there is no first stage and no rubber membrane is provided. So if I write, it is the special case of triaxial test. Cell pressure or confining pressure is 0. That is sigma 3 is equal to 0. The saturated sample, in this test, the saturated sample is subjected to axial loading and a deviator stress at failure is measured. Saturated sample is subjected to axial loading till failure. Means sigma d is equal to sigma 1, because sigma 3 is 0. So sigma d is equal to sigma 1 is equal to Qu is equal to P by AF, and this is 2 times undrained cohesion, where sigma d is the deviator stress and sigma d is same as the sigma 1, because we know sigma 1 is equal to sigma 3 plus sigma d, and as I told you earlier, sigma 3 is 0, so sigma 1 is equal to sigma d. and that will be equal to the Qu is the unconfined compressive strength, and this unconfined compressive strength can be computed as the load at which saturated soil sample fell divided by the corrected area of the sample at the time of failure, and this is equal to the 2 times the cohesion, where Qu is the unconfined compressive strength because sigma 3 is 0, hence sigma 1 is equal to sigma 3, and a unique Mohr circle is obtained, which passes through origin. So if I draw the Mohr circle for the unconfined compressive strength, so the Mohr circle passes through the origin because sigma 3 is 0, this value is sigma 1, sigma 3 is equal to 0, and the intercept, this is undrained cohesion, phi u is equal to 0. So from stress relationship, we know sigma 1 is equal to sigma 3 tan squared alpha plus 2c tan alpha. Here sigma 3 is 0, so sigma 1 is equal to 2c tan alpha where alpha is equal to 45 plus 5 by 2. For pure clay, we know for pure clay phi is equal to 0, so Qu is equal to sigma 1 is equal to 2 times C, or C is equal to Qu by 2, where already told you that Qu is the unconfined compressive strength, and that will be the half of the unconfined compressive strength is equal to the cohesion of the soil. So this unconfined compressive strength of the soil is used to measure the consistency. So with the help of unconfined compressive strength used for rapid assessment of consistency of soil for classification, clay are classified according to their consistency based on UCS. Means if the value of compressive strength is less than 25 kilopascal, so the consistency is very soft. If it is 25 to 50, so the consistency is soft. 50 to 100, then medium. 100 to 200, then it is stiff. 200 to 400, very stiff, and greater than 400 is hard. So compressive strength Qu can be computed as I told you, P by AF, where AF is equal to corrected area, as I told you for the undrained case UU test, original area divided by 1 minus longitudinal strain, where A naught is the original area, epsilon L is the axial strain, which is change in length by original length of the sample. So let us discuss another very important test, that is vein shear test. vein shear test. So vein shear test, in this test there is no mechanism to measure the pore water pressure and no drainage facility provided, hence it can be conducted only under undrained condition. This test can be performed in the laboratory as well as in the field, and the performance of the depends on the size specimen, means height and diameter. If I am using in the laboratory, so height of the blade should be 20 mm and diameter should be 12 mm and thickness of vein is 0.5 to 1 mm. If I am using in the field, so the height should be 10 to 20 centimeter and diameter should be 5 to 10 centimeter and thickness of the vein is 2 to 3 mm. And this test is suitable for the soft saturated clay to find undrained shear strength, and it can also be used to find the sensitivity of the clay. So we are going to write point wise. There is no mechanism to measure pore pressure and no drainage facility is provided. Hence, when shear test is conducted only under undrained condition. This test is suitable for soft saturated clay. Conducted in laboratory as well as in the field. The mechanism is same, the difference is only in size of the vein. Laboratory and in the field. Height of the vein, so in the laboratory it is 20 mm and 10 to 20 centimeter. Diameter of the vein, diameter D 12 mm, 5 to 10 centimeter. Thickness of vein 0.5 to 1 mm and in the field it is 2 to 3 mm. So these are the dimension used in the lab and the field of the vein. The vein is pushed into the soil and torque is applied by rotating the vein at 6 degrees per minute. The vein is pushed into the soil and torque is applied by rotating the vein at 6 degrees per minute. The value of calibrated, the vein is calibrated the vane is calibrated to a spring having torsional stiffness K, torsional stiffness K. The torque can be computed as T is equal to K into theta, where theta is the angular rotation, theta is the angular rotation of vane at which complete shear failure occurs. Shear failure occurs. And vane can be shearing in two way, that is two-way shearing and one-way shearing. So let us discuss what is two-way shearing. Two-way shearing means vane is pushed such that shearing occurs at side, and top and bottom shearing, both shearing occurs. At final equilibrium, shear occurs at all sides. When vane is pushed such that shearing occurs at side and at top and bottom, both shearing occurs. At final equilibrium, shearing occurs at all sides. So this is the vane. Applied torque T is applied, and this is the height of vane, and this is the diameter of vane. So the shear stress distribution in such a way that before failure we can see that this is the distribution of shear stress before failure. So at side the shear stress is uniform. This is shear stress. Shear stress is uniform, and top and bottom the variation is parabolic. And after failure of soil, when soil fail in shear, so the distribution of shear stress all around, that is at top and bottom and side, will be uniform. This is the uniform shear stress distribution. So the shear stress can be computed by, so total torque can be written as T1 side plus T2 top and bottom, and it will be same, T2 top plus T2 bottom. Total shear stress, total torque is torque applied at side, and top and bottom it will be same. And total torque can be written as at side the shear strength of the soil is tau, and at the side is pi dh into d by 2 plus. This will be the same, so we can written as 2 times integral of 0 to d by 2 2 pi r dr into tau into r. So total torque is equal to pi d square h into tau by 2 plus, it can be written as four pi into tau into d by 2 whole cube divided by 3. So total torque is equal to pi d square h into tau by 2 plus dq by, so it can be written as pi dq into tau divided by 6. So total torque is equal to pi d square into tau, if I take common, so it is h by 2 plus d by 6. So this is our total torque. So shear strength can be written as T divided by pi d square h by 2 plus d by 6. So this is the expression of the shear strength of the soil when both top and bottom partakes in shear. Similarly, for one-way shearing, B part, one-way shearing means only side and so total torque is equal to T1 side plus bottom parts T2. Top parts will not partake in shear bottom. So total torque is equal to pi d h1, because entire height will not partake in shear, plus tau times pi dq by 12. So total torque is equal to tau times pi d square, if I take common, so it is h1 by 2 plus d by 12. So shear strength is equal to T by pi d square h1 by 2 plus d by 12. So this is the expression of the shear strength of soil. Remember in mind that in the first formula, the shear strength of the soil is T by pi d square h by 2 plus d by 6 when top, bottom and side will partake in shear, and in one way shear, top parts will not, top end of the vane does not shear the soil. So top end so tau is equal to T by pi d square h1 by 2 plus d by 12, and this formula is applicable only when top end does not shear the soil. So we know that tau f is the shear strength of function of tau f is the shear strength, and that is the function of undrained cohesion. So it can be written as we know that sensitivity of clay. This is defined for the clay, and we know that sensitivity is the ratio of unconfined compressive strength in undisturbed strength state divided by unconfined compressive strength in remoulded state. And before that we have seen unconfined compressive strength is 2 times undisturbed cohesive strength divided by in the remoulded state. So sensitivity is the ratio of unconfined compressive strength in undisturbed state by unconfined compressive strength in remoulded state, or undrained cohesion in undisturbed state by cohesion in the remoulded state. And we can also written as sensitivity is the torque applied in undisturbed divided by torque applied in remoulded soil. So the sensitivity of the clay can be computed in the 3 terms. Either unconfined compressive strength is given in undisturbed or remoulded state, or cohesion is given in undisturbed or remoulded state, or torque is given in undisturbed or remoulded state. Then we can compute the sensitivity of clay. So let us take one problem. A vein shear test was carried out in a field to determine the shear strength of a deep-seated layer of soft clay. The vein was 11.25 cm high and 7.5 cm across the blades. That is the diameter of the vein. The equivalent torque recorded is 417.5 kg centimeter. The vein was then rotated very rapidly in order to completely remolded the soil. It was found that torque at remoulded state was 283.2 kg centimeter. Determine the shear strength of soil in undisturbed and remoulded state. So we have to compute the shear strength of the soil in remoulded and undisturbed state. So I have drawn, this is the our veins, a torque is applied, this is the diameter of the vein and height of the vein. So we know that shear strength tau is equal to T by pi d square h by 2 plus d by 6. And this shear strength, we know that according to Mohr Coulomb equation, shear strength is equal to C plus sigma n tan phi. Initially, when shear test is performed on undisturbed soil and the normal stress at that time is 0, so shear strength is equal to the cohesion. So shear strength of the soil is equal to cohesion, can be written as T by pi d square h by 2 plus d by 6. Everything is given. Torque is how much? In the undisturbed state it is 417.5 divided by pi into diameter is 7.5 whole square divided by h is 11.25 by 2 plus d by 6, and d is 7.5 divided by 6. So the shear strength is equal to the cohesion is equal to 0.34 kg per centimeter square. But this is for undisturbed state. Similarly, in the remoulded state, remoulded state, torque is given 283.2 kg centimeter. So shear strength of soil is equal to cohesion is equal to T by pi d square h by 2 plus d by 6. So tau is equal to C is equal to 283.2 divided by pi into 7.5 whole square. H is 11.25 divided by 2 plus 7.5 divided by 6. So tau is equal to C is equal to 0.233 kg per centimeter square, and this is in remoulded state. So sensitivity can be computed. Sensitivity ST is equal to C undisturbed by C remoulded, and in the undisturbed state the cohesion is 0.34 divided by 0.233, so it is coming 1.46. So dear student, today I have discussed about the two very important tests on the shear strength of soil. That is, first is unconfined compressive strength test and the second one is vane shear test. So in unconfined compression strength, we have seen it is the special case of triaxial in which cell pressure is 0, and once the cell pressure is 0, so the unconfined compressive strength is equal to the measured principal stress is equal to the load acting on the saturated soil sample at which it will fail divided by area of failure, and that is equal to the 2 times the cohesion, where AC can be computed as original area divided by 1 minus longitudinal strain, and the Mohr circle is passes through the origin we have seen. Second test today I have discussed, that is vane shear test, and as I told you, vane shear test is applicable for soft saturated clay and there is a no role of drainage, so it is conducted for undrained condition, and this test is conducted in laboratory as well as in the field. And in this test we have derived the expression of shear strength of soil in two cases. That in the first stage, when both top and bottom and side parts partakes in shear, and the second case, that is when only bottom and side parts partakes in shear and there is a no top portion will not partakes in shear. So the expression when two-way shearing, the expression of shear strength is equal to cohesion is equal to T by pi d square h by 2 plus d by 6, where T is the applied torque, D is the diameter of vane and h is the height of vane. And in the one-way shearing, the expression of shear strength is equal to T by pi d square h1 by 2 plus d by 12, where T is the applied torque and h1 is the height up to which the vane partakes in shear, and D is the diameter of vane. And after that I have solved one problem related to the vane shear test. So in the subsequent class I will discuss some more problems related to the unconfined compression test and vane shear test, and after that I will discuss what is Skempton pore pressure parameter. So take care of your health and happy learning.